And that are these, and I'm not sure where to put it under, because you could put them under two different things. Let's put it under least common multiple. We're talking about this. You're talking about, we're talking about least common multiple. And what gets very much confused with greatest common factor. And I am going to change this to a brush because I looked at this. And going back, let's go back to 5th grade, or yeah, 5th grade probably here. Okay. Least common multiple, children, is when we did multiples of something. You know, if I asked you for multiples of 6 and 8, that would be this. Multiples of 6 are 6, 12, 18, 24. Multiples go on forever. Okay, multiples of 8, if you're counting by 8, it's 8, 16, 24, 32. The least common multiple is the smallest multiple that they have in common. We do least common multiple when you find common denominators of fractions. When you add 1/8 plus 1/5, you change the bottoms to their least common multiple, which is 40. Okay? When you add fractions, that's what you do with this. Okay? Greatest common factor, okay, deals with factors. If I said factors of 6 and 8, factors of 6 and 8 are what times what gives you 6? Well, 1 times 6 and 2 times 3. Factors of 8 are 1, 2, 4, and 8. We've done this since 5th grade. Okay? You use the greatest common factor when you reduce fractions. By the way, we did this last year, 7th grade, 2 grade. Now, the difference is we're going to start doing both of these with more complex things than just numbers. You're going to throw variables and letters and all that sort of stuff in there. With me here, but it's good to keep these straight. Multiples go on forever. Factors, there's a finite amount of, there's only so many of them that you'll ever get. So here is the deal, and this gets put under the same category because you start it all off the same way. I really need to go to this is LCM and this is GCF. So let me give you actually tomorrow's worksheet so you can look at and see what we're going to do. The other time you use the greatest common factor is if you're asked to factor something out of something, you always want to use the greatest common factor. And we are going to talk about a really kind of long process to do these, which many of you probably can do in your head just by looking at them. But if you can't do it in your head by looking at them, then you kind of are forced to do it kind of this long, drawn out way. And some of you are like disillusioned with the fact that you can do them in your head and still you can't. So you may want to like do a few of them the long way first. So take a look at, let's just look at problem number 1. I'm going to start with the new screen here. Oh wait, no, I'll go. Problem number 1. And then I will give you the process for this. Okay. Let's do, oh, why is this doing this? Let's do this. Okay, here are your steps actually for both. We're going to write both of them down. What was it? Least common multiple first? Yeah. Least common multiple, greatest common factor. For both of them, your first step is you need to prime factorize everything. And again, like I said, well, you'll do a couple of these, and then I don't think you probably will have to do all these steps, but this is your thought process. So here I am. I've got 33y squared. I've got 22xy cubed, and I have 22xy squared, right? If I prime factorize those, what do those break into? Well, what times what gives you 33? 3 times 11, thank you for whoever was thinking that. What does y squared break down into? Y times y. Are you with me? Y squared, 2 y's, 33, 3 times 11. Stop me there if that didn't make any sense. I'm just trying to factorize it. What does 22xy cubed break down into? 2 times 11 and x times y times y times y, right? Feel free to agree with me at any point. And then what does 22xy squared break down into? 2 times 11 times x times y times y. Okay? Now here is where they split off in what you do. So this will be step number 2. To find the least common multiple, you take the greatest amount of factors that appear in your prime factorization. You probably can't read that or see that. You take the greatest amount of factors that appear in the prime factoring. This makes more sense when you figure it out than when you read that sort of thing. Better? Yes. I can't believe I'll be able to see this here. That just means this, children. Work with me here. Here's my 3 different groups. See my 3 groups? I've got this group. I've got this group. I got this group. And I got this group. I look at those and I go, okay, which group has the most, well, let's start with the smallest factor, 2's. What's the group has the most 2's? Well, these 2 are tied with just 1, 2. So you just take 1, 2. Write down 1, 2. Which group has the most 3's? This one, it just has 1. Which group has the most 11's? All of them have 1. You don't take 3, you just take 1. They don't have any other, there's no other number factors that either group has, so you don't have to worry about, don't worry about 7's or 5's. Which group has the most x's? This one has 1, as does that one. And which group has the most y's? This one, with 3 of them. Your least common multiple is what you get when you re-multiply all this, which would be 2 times 3 is 6 times 11 is 66, x, y to the 3rd power. If you were trying to add fractions together that had those as their denominator, this would be what you'd have to change them to, because this is the smallest number that all 3 of them will go into. For example, I started with what, 33, where is it? I started with 33y squared. If I had 33y squared, and I wanted to make it into that, what would I multiply it by? 2xy. If I multiply by 2xy, I get 66y cubed. If I started with 22xy, I could multiply by 3y squared, and so on and so on. This is the least common multiple, LCM. The smallest thing that all 3 of those will go into. Okay? Now, how is that different than greatest common factor? That's the next one we have to talk about. And we'll do a few of these, though. If you don't quite catch on to it right now, don't worry. There'll be more. Okay? Now, if you want to go to greatest common factor, you don't do this. Okay? You take, for greatest common factor, you just take the factors that all groups have in common. If you're looking for greatest common factor, you just take the factors that all groups have in common. Let me look at this. Can I move over here? What's that? Can I move down here? I'm going to do this. I'm going to rewrite my factors down again. What were they? Somebody going to help me out here?
Wait, is the first rule to prime factorize for greatest?
Yes. You prime factorize in both of these. So here were my factors. I had 3 times 11 times y times y. I had 2 times 11 times x times y times y times y. And I had 2 times 11 times x times y times y. Okay? Here is the deal with greatest common factor. In order to take the factor, all the groups have to have it. So I look over here. Does every group have 1, 3? No. So I'm not going to have any 3's in that. Does every group have a 2? No. 2 of them do, but the third one don't. So they don't all have it common. Does every group have an 11?
Yes.
Yes, and they just have one of them. Does every group have an x? No, so you don't take any x's. Does every group have one y? Yes. Does every group have a second y? Yes, so you take 2 y's. When you remultiply this, 11y squared is your greatest common factor. Which only makes sense if you went back and looked at your thing. You could tell me that without doing what we just did. You could look at that and say, well, what can I take out of all these? I can take an 11 out, and I can take a y squared out. This one doesn't have an x, so you can't take it out. But this is kind of the long way kind of to do that. Now you say, let's try a couple. Let's go down to the bottom of your worksheet. Let's just do this one. First of all, you might be able to tell me what the greatest common factor is by just looking at this. You look at the number 32, 48, and 64. Let's do it. What's the biggest number you can get out of those? 12 doesn't go into 32. 8 is the biggest number you can get out of all of them. Sometimes people get confused with the number. What's the biggest? Do they all have a y in common? No, so you can't take a y out. What about x's? What do they have in common? 2 x's, which is x squared. Okay, that is going to be it. Watch, I'm going to do it the long way out with factors. What times what gives me 32? 2 times 16, 2 times 8, 2 times 4. Take my word for it, that's 32 factored out. Times y times x, correct? 48 is 2 times what? 24, 2 times 12, 2 times 6, 2 times 3. And you have 4 x's. 64, did we already do that? It's this with one more 2, 6 2's. 64 is this. 6 2's and 3 x's. Okay, that's the prime factorization of all those. I'm not going to spend forever doing that. What do they have in common? They have, wait a minute, this one, I did this one wrong, didn't I? 16 times 3 is 48. 32, did I do this wrong? 2 times 16. Wait, did we do something wrong? Let's check and see. What do they have in common? How many 2's do they have in common? 4, do they not? Should not this have been a 16? Because 2 times 2 times 2 times 2 is 16. 16 goes into 32, 16 goes into 48, 16 goes into 64. And what do they have in common as far as letters? Well, 2 x's. 2 x's is the most they have. So the answer should have been 16x squared. A number higher than 8 went into that. If I asked you for least common multiple of those, you're going to take the group that has the most of each one. Which group has the most 2's? This one over here, which had what, 6 of them? 2, 2, 2, 2, 2, 2, 2, 2. Which group had the most 3's? This one, which just has 1. Which group had the most y's? This one, which just had 1. And which group had the most x's? This one, which has 4 of them. And multiplying all that together, you get what? This was 64 times 3, 192 y x to the 4th. If these were on the bottom of a fraction, you'd have to make this your common denominator, because it's the smallest thing that all 3 of those will go into. And again, you might be able to see that, and you might not. It's pretty hard to pick this one out. This one's pretty easy because you know they have to have. Should we try another?
Yes.
11. Sure, I'll let you do, you try 11. And this is greatest common factor, not least common multiple. Greatest common factor, what's the biggest number that goes into these? And then what do they have in common as far as factor goes? After you do this a couple times, you'll be able to say, well, I don't need to do all that factor stuff because I can see it. I will prime factorize it while you're looking at it. How's that? You have an answer, Alex Knopf? 10m. Well, let's look at the numbers. What do I have in common? Do they all have 1, 2 in common? Yes. Do they all have a 5 in common? Yes. Do they all have a 7 in common? No. Do they all have at least one n?
No.
No, that one doesn't have an n. Do they all have at least one m?
Yes.
Yes. They don't have 2m. So it is 10m. Okay. That is what people, if you saw this, if you saw as a problem 70 nm plus 20 nm plus 20m squared. Did I run out of room again? Sorry. Plus 20m squared. And they asked you to factor out what you could take a 10m out of all of them. And what would you be left with? You have a 7n, the 7n times that gives you that, plus a 2n plus a 2m. If you were asked to factor that out. How many of you could look at that and say that was my greatest common factor? It gets a little confusing at times. Let's go back up to least common multiples now. Least common multiple of this. The number might be kind of hard to do. The letters you should be able to do because you just take the group that has the most of each thing. In other words, what group has the most a's? This one with a squared, right? Which group has the most b's? This one with b squared. But what's the least common multiple of 48 and 56? Yeah, that one you probably might have to do it out. What is 56? 2 times 28, 2 times 14, 2 times 7. What is 48? 2 times 24, 2 times 12, 2 times 6. And then you take the group that has the most of each thing. Which group has the most 2's? This one. Group has the most 3's? This one. Group that has the most 7's? This one. We have to remultiply all this out, which is what? 8 times 7, 56 times 3. 56 times 3 is what? 166? 168? 168 a squared b squared is your least common multiple. Would you like to try a few?
Yes.
you go do a few. If you're still questioning it, do one, come talk to me and I'll get you straight away. The first step in all of them is to prime factorize. If you prime factorize, your work is pretty much done. So, remember, for the factors, you take what they have in common. For the multiples, you take the group that has the most of each thing. Don't you worry, you will be all set.